We want to solve quadratic functions by graphing and factoring, and we want to solve quadratic equations algebraically by factoring. So here we have negative 3y plus 28 is equal to y squared, and we see the y squared, so we know that this is a quadratic function, and we need to get one side of the equation equal to 0. The issue is here we have y squared on this side, but it's positive, and we like to have our highest degree positive. So what we want to do here is we want to move these two over to join that. So we're going to add 3y and add 3y, and then we get 28 is equal to y squared plus 3y. Then we want to subtract 28 because we need to get 0 on one side. And then we get 0 is equal to y squared plus 3y minus 28. So then we can factor from here. And when we're thinking about this, we still want 0 is equal to, and the only thing that we can do to get y squared is we can say y times y, and we need two numbers that are going to multiply to negative 28 and add to positive 3, and we can pick 7 and 4, and it needs to be a positive 3, so positive 7 and negative 4. Then we can use our zero product property. So zero product property, and we can set each equal to 0. So 0 is equal to y plus 7. So we subtract 7, and we get y is equal to negative 7. And over here we can say 0 is equal to y minus 4. So we add 4 and add 4, and we get 4 is equal to y. And so we have two distinct solutions. So this is a multiplicity of 1. Next, we're looking at m squared equals 7m. And again, we have the m squared on the left side is positive, and we have 7m over here. So we see the square. In order to solve a quadratic, we need to have 0 on one side. So what we want to do is we want to subtract 7m from both sides. And then we get m squared minus 7m is equal to 0. And at this point, we have two terms, and both terms have m in it, so we can factor one m out. So we get m times m minus 7 equals 0. So we still have a product because m times the binomial m minus 7. So we can still use the zero product property. And what we want to do is we want to set each of these equal to 0. So we can say m is equal to 0, and we can say m minus 7 is equal to 0. And when we do that, this is already solved for us. M is equal to 0. If we set m equal to 0, m times this binomial, the whole thing is 0. We don't have to do anything else. That's already set. So here we can have add 7 and add 7, and we get m is equal to positive 7. Again, we have two distinct solutions. We have m equals 1 or 0 and m equals 7. So this has a multiplicity of 1. So multiplicity of 1, so we have two distinct solutions, m0 and m equals 7.